What's up guys, today we're doing some pool physics. Okay, in this video we're going to be looking at the interaction of the white ball in pool to two other balls that are at an angle to each other. So we're going to look at the relationship between the angle and the relative motion after the collision. So you can see the angle here is 46 degrees. If we play, once I play the simulation, we're going to see this ball on the left, the white ball, come towards the right at 10 meters per second, and it's going to have a collision, and we're going to look at the motion of these two balls here. So here we go. So as you can see, the collision was made, and these two balls are going out at an angle, both going out at an angle from the horizontal, and we're going to analyze that and see how the location of the angle between the two balls affects this motion after. So yes, let's get into it. I decided to make this video because I noticed that if you angle the two balls to one of the holes and then you hit the center of the ball closest to you, the two balls will go in each one of the holes the majority of the time. I don't get it perfect every time, so sometimes I miss, but when I do get it right, it does definitely work. So in order to understand what's happening here, we need to look at the momentum transfer between the two balls and the position of the two balls on the table, okay? So the first thing we're going to look at is the position. As you can see here, the two balls are located at, I don't know if you can see it, but there's the black dot where you put the cued balls for a game, okay? So the black dot underneath there, which represents where you put the balls for a game. This point is at 1/4 of the length of the table, okay? So the length of this table is 1.68 meters. So this is going to be 0.42 meters. Okay. Similarly, the center of this the two balls is going to be lining up with the center of the table. So if I draw a line here, center of the table. Okay. So this the length of the table is twice the width of a pool table. So this distance here is also 0.42 meters. Okay. So we're going to have an angle of 45 degrees here. Now, the angle here is 45 degrees, and the angle between the green ball and the orange ball is also 45 degrees, okay? Because it's lined up, it's all lined up through each other. So we have the arrow going through the center of mass of that ball, center of mass of that ball, and the hole, okay? So the momentum of the white ball is going to be equal to m times v. Okay? That is the equation for momentum. Here's the momentum. We're not going to go too deep into that. We just need to know that the white ball has momentum. Okay? Okay, so now, if the white ball comes in with its momentum and transfers it to these two balls, okay? So it transfers it to the green ball first, and then that green ball transfers some of it to the orange ball, okay? The direction of this transfer from the green ball to the orange ball, well, we knew that the angle between the two balls was 45 degrees. So this angle here, which is the transfer momentum angle, should be 45 degrees. Okay? This, if we put it in our momentum diagram, so this diagram, this is the momentum of the white ball. That's momentum of the white ball. And then this is the momentum of the orange ball. And so this is going to be at 45 degrees here. 45 degrees. And that means this is going to be 45 degrees. Because it's a 90-degree angle. Okay, so that's the direction of the momentum transfer to the orange ball. And in order to have conservation momentum, this green ball needs to close the triangle. Okay, so this angle here also needs to be 45 degrees. Okay, so this angle here will be 90 degrees. That's how the momentum transfer is going to work. If each ball has 45 degree momentum, then we're going to get the following situation where each ball goes into the hole. Okay, so if you take 45 degrees from here, you're going to go into the hole. 45 degrees from here, you also go into the hole. So this one's 45 degrees like that. Okay, and that's just because of the position on the table. Okay. So as I continued analysing the momentum transfer between the two balls, I found that as you change the angle between the two balls, the angle between their two paths after the collision remains at 90 degrees. This means that by changing the angle between the two balls and the position of the collision, I can make the two balls go in both holes from different positions along the table.
Let's go.
Okay, so what I've done here, I've got two strings. I've got one going from that corner to this corner, and that's going to be used to find the angle from the hole to the ball. And you can't really see the string. Angle to the hole of the ball. And then I've got another string here that I'm going to use to find the location on the circle from the origin here, which I will put my finger down to make sure it doesn't move too much. And I'm going to use these two to find where I need to place my ball, my two pool balls, and then also at what angle they need to be on. So this one's used. This one going from corner to corner, I'm going to use for the angle. This other one I'm going to find the location where the top ball needs to go. So let's try this out. That just worked first try. Let's go. I did not expect that. It worked perfectly, so I put it like around like this area here. Had both balls. I had it angled toward the hole. Came in, knocked it straight in. That hole, one of them went in that hole, and this one went in this hole. So I'll get an actual video of it now, and we'll get after it. Here we go. Holy moly! Let's go! That's the video, guys. Hope you enjoyed it. Trick shot to end it. Here we go.